All right, graphing. If we want to graph y equals 2 to the x plus 2, I'm going to want you to identify these things before getting to the graph. First of all, where's the asymptote? And the asymptote is always going to be whatever constant is added to the exponent. In this case, that's 2, so our asymptote is the line y equals 2. The y-intercept, that's going to happen when x equals 0. So plug in 0 for x. Y is equal to 2 to the 0 power plus 2. Well, 2 to the 0 is 1, and 1 plus 2 equals 3. So that means 3 is our y-intercept. We can tell if it's going to be growth or decay by looking at the base of the exponent. If this base is greater than 1, like 2 is, then it's growth. If it's less than 1, it's going to be decay. So for this situation, the base is bigger than 1, meaning that we're talking about exponential growth. Now we have a lot of really good information in order to come up with an excellent graph. First of all, the asymptote being at y equals 2. Find y equals 2 on your graph and draw an asymptote with a dotted line. Maybe even label it with the number 2. The y-intercept is going to be at 3, so go up one more and put a dot there. Maybe even label it as 3. Since this is exponential growth, it's going to grow away from the asymptote. So make a nice little curve. Don't let your curve cross the asymptote. And there's a really good graph. So let's do one more that's a little bit different. Y equals negative 1 times 1/2 to the x plus 2. Again, we're going to try and find the asymptote, and that's what's being added or subtracted to the exponent. And in this case, there is no constant at the end. That means that our asymptote is going to happen at y equals 0. Again, to find the y-intercept, we're going to let x equal 0. So we'll get y is equal to negative 1 times 1/2 to the 0 plus 2. Well, 0 plus 2 is 2, and 1/2 to the second power is 1/4. So our y-intercept is going to happen at negative 1/4. Last thing before we get to the graph is to determine whether it's growth or decay. And again, we look at the base of the exponent, so only what's in here in parentheses. Now, since this base is less than 1, we're dealing with exponential decay. So what's this graph going to look like? First of all, graph the asymptote. Y equals 0 means the x-axis is our asymptote. Our y-intercept is going to happen at negative 1/4. So if this is negative 1, our y-intercept is going to happen at negative 1/4. We do know that there's another important point, and we can find that by making the power equal to 0. And so that means, if we were going to make a table, we're going to have to let x equal negative 2. And when we plug in negative 2 right there, we'll get negative 1 times 1/2 to the negative 2 plus 2, which is 0. 1/2 to the 0 is 1, and that means that y is going to equal negative 1. So here's one more very important, very nice point, and that happens at negative 2, negative 1. Having that point is good for us because it kind of defines the curve a little bit better and helps us to see maybe where that decay is going to happen. When we have the exponential curve reflected over the x-axis and we're dealing with decay, your instinct is to let the curve continue negatively, but that's not what decay means. When we're talking about decay, we're going to let that curve decay towards the asymptote. So it actually continues to grow positively, but it decays towards the asymptote.